Welcome to CNC Tips and Techniques. I'm Randy Johnson, and in this episode, we're going to take a look at some questions that have come in recently and go over those. They cover a variety of topics. I had several people ask about how to get started in CNC, especially with VCarve and how to set up their shark machine, as well as some people had some questions about some machining problems, so some common issues that they've run into. And then I had a variety of VCarve specific questions. So we'll take a look at those as well. To start out with, I'm going to look at the getting started questions that came in, and they fell into two groups. One was the VCarving training questions, the other was machine setup. If you're just starting out with CNC or VCarve, you know that the learning curve can be really steep in both areas, but particularly the VCarve area. That's why I like to point people towards the idea that if you start small and start simple, because there's so much to learn to start with, just keep it simple, as they say, and get a couple test projects under your belt, and you'll pick up things along the way. But next, I want to share with you several resources that are available for free of charge for VCarve as well as the machine setup aspects. Now, if you've got a Vectric account, which you will if you have the Vectric software, but just go out to the website, and underneath their support column, they have some really good training videos and some other introductory information. The training videos in particular, they've got dozens of them, if not hundreds of them, available along all topics. And the topics are arranged based on the piece of software you have. So if you have VCarve Desktop or VCarve Pro or Aspire or one of the others, you can select that, and then the videos will be filtered for that. You'll also notice that the videos are set out based on whether it's beginner, intermediate, or advanced level. So you can pick a topic. They tend to be all project oriented. So when you open one of them up, you actually have a project that they're going to guide you through on how to design it and how to do the tool pathing for it. There's not a lot of machine discussions in these videos. They're primarily about the VCarve software, and that's why they're so good for that aspect of it. Also, on their website, you'll notice that here on the left side, or rather the right side at the bottom, there are some bookmarks talking about the various topics that are in each video. And those are very helpful as you're going through and you want to jump to a different section or repeat a certain section. Also, right below the video, you'll notice an install and a download link. The install link will put a shortcut on your computer that when you click on it will then actually do the downloading for you, or you can actually click the download. It'll depend a little bit on how your computer is set up, but one or both of those links, if you click on them, they basically do the same thing, and they download the video, and if there's a VCarve file, it'll download that, as well as if there's some art that go with the project, it'll download that also, and that'll all be loaded onto your computer, so you can have easy access to it. You don't necessarily have to go back to the website then for it. Additionally, once you get out to your software, to the VCarve program, you'll notice they're halfway down on the left side. If you want to go back to the tutorial videos on the website, you could go back and just click on that button. Or if you have videos that you've downloaded, if you open the tutorial files, that'll actually open up the folder on your computer where they have been saved automatically. So you got two options there readily available to you. Also, inside the software itself, there's a couple of spots where you can find some quick help also. These question marks that are in both the left and the right side of the software, when you click on those, it takes you to their user guide on their website. And it's a dedicated website set up just for the user guide to the current version that you are using. And at this beginning here, halfway down the page, you can see where it says you've got the menus highlighted there, and click on those. It'll take you to all those options or all the items underneath one of those menu items for help on those categories. If you scroll partway down the page, then you'll also see some pictures of the various tool panels that are available within the software. And what's nice about these is if you click on any one of the individual tools within those menus there, it'll then take you to that page on this user guide in this website. Also, back in the software, if you open up a tool like the draw circle tool or the chamfer tool on the right, you'll see that the question marks are still available. And when you click on them within a tool like this, it takes you to this specific page automatically. So in this case, let's click on the chamfer tool question mark, and it pops you right over to the website to the chamfer toolpath section. And there are often videos available right on that page as well. And you can find all the specs as far as what the different settings do within the chamfer toolpath. So it's a great way to drill down into any given tool if you want to find out more about it. In a similar fashion, out of the NextWave website, for those of you using a Sharp machine, if you go to their support section, they also have a group of items at the top of their support tab, which can be particularly helpful. The Help Center is again, much like the user guide over at Vectric, the Help Center at the NextWave site is a site dedicated to tech support resources, a lot of help menus, you go in there, you search for a topic, and it'll bring something up, a page on a particular topic that you're looking for information on. The FAQs, of course, are common questions that you might come across, so that can be helpful. The webinars and training page, you can find registration links to future webinars as well as links to past webinars on that page. And the instructional videos that it shows here, that's for machine assembly if you want to get some information on that. And then, of course, all of the product owner manuals are also available for download for your current product or for other products that you're considering possibly purchasing. Want to point out that on the webinar page, there's also these 3 webinars. These are past webinars. These are 3 key webinars that I've done for NextWave. And the Getting Started one is a very basic one, orienting you to the machine setup. The middle one is on the LCD, both covering the small LCD pendant as well as the larger 10.1. And on the right is the Ready to Control software. These videos are regularly updated every few months. We'll run a new video as they add new features to all these areas. So you could go out there as well. The LCD pendant one particularly is useful once you get up and running because it goes over in great detail the settings. And again, like I said, they're adding new settings along the way, so it may not cover all the settings that your current pendant has, but in the near future, that'll be upgraded as well for the newer features that are being added. Next, we'll take a look at it. One of the questions that came up with machine questions, what accessories should a person consider when they're getting started? And there are some basic accessories that you can add to your machine that are particularly useful. One of them is a spoil board. If you have one of the larger machines with a T-track bed on it, either adding the spoil board that NextWave provides from their website, which is made out of this black MDF, and it's all pre-bored for the countersink hold downs. That'll just strap or bolt right down to your existing table. Or you can also make your own sectional spoil board out of MDF and counterboard and hold it, bolt it down as well. The sectional spoil board allows you to use clamps as well as screws or other types of hold down methods, so it can be valuable that way. Another option, my favorite actually, is a 2-part spoil board, which uses a piece of plywood that gets bolted down to the tabletop, again with counterboard holes. And then to that, I glue a piece of MDF to the top and weigh that down with some bricks so it's nice and solid. And you want to use plenty of glue because the MDF and the plywood absorb a lot of it. You want this to be one solid sandwich. So I usually add some blue tape around it to keep the glue from dripping onto the T-track table. And then you could go back, use a surfacing bit and surface this, and it makes a great tabletop for doing your projects on for cut throughs. And you could just resurface it. And as it gets thinner and thinner over time, when it gets down to maybe 1/8 of an inch on the MDF, then you can simply glue a new piece of MDF on top of it, and it's continually renewable that way. You'll also find that if you go out, on the internet and explore different options and different ways people have set up their spoil boards, you'll find many, many variables out there. This is one that's kind of my favorite in the sense that this guy's kind of included everything in it. He's got T-tracks built into his sectional spoil board. Since he also has another track, it looks like another piece of material below it. He has some holes and some grids and some fences, all for alignment. So there's just lots of ways, pretty unlimited options for how you set up your spoil board. And so that, again, provides you lots of flexibility when you're doing different types of projects. One other accessory that's pretty handy if you have some sort of dust collection available to you, or even a shop vac, is a good dust boot. This is the Dust Boot Pro from NextWave. It's a 3D printed object with that mounts to the front. That brush on the bottom is detachable, so it makes it easy for changing router bits. So this one is particularly effective because it also has a larger hose attachment to the top. If you're looking for some sound or dust enclosure prevention, consider putting some sort of enclosure around your tool. This one is made out of what's called 80-20 aluminum with fasteners on it. These are custom built. You can either work with a company that builds these, or you could possibly find something on the internet that is pre-built. But one other option that you could use is actually buy your own material and make it yourself. These enclosures are particularly useful if you want to keep the dust and the sound enclosed in your shop. One of the sources for that material is called 8020.net, and they carry a variety of the T-slotted aluminum as well as the quick connects and other types of fasteners. They even have an app on their website that allows you to design your own enclosure. So if you're looking for something like that, check it out. It's not it's not inexpensive. It does have a bit of a price to it to do it, but it ends up being really nice. Of course, you can also do your own with a shop-built plywood or wood cabinet and use some plexiglass for the windows. I built something similar to this for one of the machines I had. Made it a lot taller than the one you see here, however, to fit the machine in. I also just used plywood on all the sides except for the doors, and then I just put some LED lights in to give illumination to it. So pretty unlimited, again, what the options are, but it makes a nice shop project also for enclosing it, and probably more economical than doing it out of the aluminum. Now, one of the other accessories that people like to consider is the laser. Now, NextWave carries a 10 and a 20 watt laser. And one of the common questions that has come up around that is, what is the capacity for that? Well, you can see noted here that from the NextWave specs, they show that the 10 watt, 20 watt can cut through 0.3 or 0.47 thick wood, respectively, depending on how fast you're traveling. Now, it shows that at 3.5 and 5 inches per minute for these two lasers, that's super slow, and that's fine, but that's what it takes. My experience has showed me with the 20 watt is that rather than traveling 5 inches a minute, which can cause some scorching, as you can see in the picture on the test grid, is I tend to go with 4 passes at a faster pace, or 5 passes. You just have to test depending on the kind of wood you're cutting. I commonly cut 1/8 inch plywood with mine, and it'll take 4 or 5 passes at 100 inches a minute. So I keep it moving, and that way it scorches less. It just goes around it several times. This test grid is available from the Help Center out at the NextWave website. And you can run this with either the 10 watt or the 20 watt, and you can run it on different kinds of materials, different thicknesses of materials, and it'll give you some idea of the type of speeds and feeds that you're going to want to use then when you're cutting your actual project. But it's a great way to test it. Probably one of the other common questions I get is people have problems with movement or cutting errors on their machine, and the reason for this are numerous. It can be everything from mechanical to VCarve setup to router bit. And I've got a long list here of things you can look at if you're having a movement or cutting problem. And you kind of got to think about, okay, is it just a movement problem or something with the router bit? And I would usually go back to VCarve and double check that your VCarve vectors and toolpath are set up correctly. And then when you get your machine, double check that all your zeroing is set up correctly. And then watch your machine, run another test, run another file to see if the one file works and the other doesn't work, then you've isolated it down maybe to that file. If the problem is occurring with all of your files that may be related more to your setup or your machine than to your VCarve file. A couple things that can commonly cause cutting or wrong movement if the machine is not currently lubricated correctly. In other words, you haven't kept up your maintenance, the rails and the threaded rod can get dry, which can cause it to hesitate while it's moving around. Also, if you leave a tool on the table, it could jam underneath or next to the gantry. So just check everything like that. And usually you go through some of this checklist here, and you can usually boil it down to what it is. In the end, however, if it does end up being something that's really random and you can't really repeat it, or maybe you can repeat it, you may identify it as a mechanical or electrical problem that you may then have to call tech support for help on it. One other thing that comes up is people often report that their VCarving leaves lines, and there are a couple of reasons for this. The first thing I would consider is that make sure you're using a good quality bit, a V-bit. This is one of my favorite bits that I use. It's an Amana tool. It's an insert router bit. It's surprisingly economical to use because the bit, as you see it here, is like maybe $35. And then those inserts run about maybe $7 or $8 a piece, but each one has, there's 4 tips on that insert. So you can use it 4 different times. So it really brings the cost down. But what I also really like about it is that insert is super sharp, has a very nice point to the tip. So you get very crisp V-carving with it. But sometimes people also, so they got a good bit. Next, sometimes I've seen people get lines on their projects from they're being too aggressive with the pass depth. So try reducing your pass depth a little bit and see if that helps reduce the number of lines, because when you're too aggressive with the pass depth, I've seen people go 1/4 inch, 3/8 of an inch, and that's just a lot of material, especially in hard material. And that will put some stress on your machine and may cause some flexing someplace in the system. And it doesn't take much to then have those lines end up at the end. But also related to that is tramming your spindle. And what tramming refers to is that if your spindle is not perpendicular to your work surface, then of course your router bit ends up going in at an angle, and that also will leave marks. The image there on the left is somewhat exaggerated, but you can see there how if that V-bit is going at an angle, it's not truly a 90-degree angle any longer, or a 45-degree angle on each side of that V-bit. And that will then also leave some lines. So the way you can check for that is if you have a spoil board, you do need to have a spoil board to tram your machine. But after you run your spoil board bit, if you're getting ridges in your spoil board that are noticeable, or if you just put a piece of paper on it and you rub it with a pencil, and you see those lines, that means you do need to tram it. Now, it's pretty easy in the sense that to identify this, and it's also fairly easy to tram the machine. It will depend on which machine you have. So I've got a couple techniques here that I use to set up, get that perpendicular to the table. But once you get that tuned in, you should have a nice smooth surface that the most you see on there is the fuzz from the router bit moving around, and you shouldn't have any ridges. One of the tools I use for that is this shop-made tramming jig. Now I know that there are measuring tools and different calibers and different, devices that you can buy for this to do this, but I've used this setup for 20 years in CNC, and it's so simple. And I just don't use anything else because it just gives me everything I need as far as measuring the table, as far as having to tram it. Now, the way this works is that this trammel tool swings around 360 degrees, and you swing it to the left, and you swing it to the right, and then use your pendant to go up and down with it until the bolt is just scratching the surface of the MDF, or maybe you put a little piece of paper under it. You swing it back to the right again or to the left, and you look for which side is high or low, and then that will show you how far off your spindle is as far as it being plumb with the table. And then you do the same thing front and back. Now you want to surface your table first. So even if you have ridges in it, this technique will still work. And you go back and forth on it. And I have a handout that's available in the description below. And also that for those of you who attend the live video, the live webinar, you'll get that in your email. But otherwise, this jig works really well. And at the end of the day, you'll end up with a really nice surfacing on your spoil board, which will then eliminate one more possibility of why a V-bit is leaving marks. Again, you can tram it, run a test cut with your surfacing bit, and if you need to, go back and retram it again. Now, again, the handout that I have is specifically for HD5 and HD6 tools. You might be able to adapt it for some other tools, but if you have a different tool, you have to look at the mechanics of how your Z-axis is set up as far as how you would make those adjustments. Now, the last option to look at, if all three of those don't solve the problem, there is a way to add a cleanup toolpath that I would say 95% of the time will get rid of all of these marks, maybe 100% of the time. And I'll take a look at that. So next, we're going to go ahead and jump into VCarve and take a look at how to set up that cleanup toolpath. So this is that similar image. I've simulated what those lines look like, both with the chamfer and a V-bit. And let's go into the 3D view. And I'm going to run that simulation right now on the VCarve lines. Open up our preview window. Okay, so there you can see that we have those lines like that. Now, that's somewhat exaggerated, but to solve it, open up your VCarve toolpath that you just ran, add a little bit of start depth. Now, you might put 0.05 to start with, or you might find you have to go to 0.005, or if that doesn't prove to be enough, you could type in 0.01. Usually, one of those will be enough to remove all the lines. Let's just do a tester, start with 0.05 at a start depth. But the other thing we want to do, and this is really important, is we want to go in to our tool bit and we want to give it a pass depth. In this case, I've already changed this. My usual pass depth of this is probably 0.05 to 0.1, but I'm going to change this to 0.3 to make sure that it cuts it in one pass, whereas in multiple passes. And that way it uses the entire edge of the router bit to clean it up. So these are the two things you have to do. Add a little start depth and then set up your pass depth so that it'll do it in one pass. And we can tell that when we calculate this out, we can tell it's one pass because we have a single blue line going around here. So all we have here you can see it from the bottom view. It's doing the edge and then it's going up in the corners. So let's go ahead and preview that and see how that looks. Let's just slow it down a little bit. There we see it going around and then doing the corners, and there it is. It cleaned it up. And that's usually what I experience when I do this cleanup toolpath on the V-bit or a V-carving. Now, this is going to depend a little bit on the complexity of your V-carving and such, but this is one option that you have if you need to go back and clean up some of those lines. In a similar way, we could also do the chamfering. Let's do the chamfer sampling here. There, we've got some simulated lines on that edge. And we basically do the same thing. Open up the chamfering toolpath. I've already added my 0.01 start depth, which is going to drop the bit down a little bit. I've also added my pass depth to 0.3. In this case, we see that our cut depth is only 0.25. And so that way 0.3 will certainly cut that deep. And once again, we want this just to be a single pass. And there we can see the blue line just going around the entire area. So let's preview that. And there we are. It's all cleaned up. So that's kind of a last option. I would certainly pursue the other options first, because once you get your tool finely tuned, you can usually remove most of those lines. But in the event that you still get some lines, that I occasionally do, depending on my material and my project, I'll often go back and add this little cleanup chamfer line to it, or cleanup line toolpath. Okay, so next up, let's take a look at another question that's often come up. People have a lot of questions about feeds and speeds and don't have time to go into all of those, but we will take a look at some of the basic information. And in particular, we're going to talk about these three bits, the end mill, the V bit, and the ball nose. And then we'll look at a couple of applications for it. Now, within these charts here, what this shows is I've got some recommended speeds, and this is based on the Shark HD or the Shark Next Wave CNCs, and this information will apply to most of those tools. So let's just take a little closer look at the basic end mill setup items or settings. First off, you're either going to have a single or a double flute. That's the most common for woodworking on the CNC. The advantage of a single flute is that it's actually going to give you a larger chip load, which is this item down here. But it also will then, it gives you a little thicker chip load. And especially if you're running one of the trim routers or one of the smaller tools, it's really nice because those trim routers run at a very high RPM. So using a single flute, if possible, when possible, is a good idea. Now, on the spindle speed, somewhere between 16 and 24,000. If you have a spindle, the 2-horse or the 3-horse, that's a good range. I find myself most often running somewhere around 20,000 plus or minus 2,000, depending on my material and my bit. And then I'm also doing that because I'm targeting a chip load of 0.02 to 0.01. Now, you don't control the chip load from this one. That chip load is automatically calculated based on the flutes, the spindle speed, and the feed rate. Those three items, if you change one of those three, this chip load will change. Now, you have to be somewhat, especially these two, there's a range, again, with this range of 16 to 24 is usually where you want to be. And like I said, usually somewhere in the middle is usually where I end up. And the feed rate, depending on which tool you have, you do also have some limits on that, as well as what kind of material you're running. So you will have to run a few tests on this, but if you stay in these ranges, most of the time you'll be running at a safe, conservative range, and it should work out pretty well for you. Same thing with the plunge rate. Again, that doesn't affect chip load, as they call it, but it does affect how quickly it drops down into the material. And both tools have a maximum plunge rate. The HD5 is 100, the HD6 is 200. So you do have some options there with a little bit of range. But depending on what you're cutting, you may or may not want your router bit to plunge down quickly into your material, especially if it's harder, or if you're doing a particularly deep cut, you may want to slow that down a bit. Now, the path depth of the step over, they also don't directly affect chip load, but they are more like, if you think about how much weight you could put in the back of your pickup truck or in a trailer, the more you load these up, the more burden or the more load that you're going to put on your router bit, on your spindle, and on the motors on your machine. So that's what that affects. And of course, you put too much load on your machine by these being too aggressive, then you can also end up causing to stall out, break a bit, skip a step on the motor. It can cause other kinds of problems. So usually you're going to want to be in somewhere in this range. You can sometimes be more aggressive, but again, do some testing on this. I find myself, I would rather go a little lighter on my path depth and step over, so that I keep my feed rate up in order to keep a good chip load. There's a lot of compromise here, but they all work together. Ideally, you're wanting to have a sufficient chip load. You don't want to be producing sawdust. You want to be producing at least little shavings or little chips, because those little chips actually help keep your router bit cool. And if your router bit overheats, what can happen is it'll actually prematurely dull your router bit. And you're also kind of wasting time if you're going really slow. I often find people operating their machines usually at a feed rate that is much slower than they have to operate. But you also want to be careful you're not cutting too deep in a single pass. So do some tests, do some experiments. There's a lot of settings here, obviously, to work with, and just run a couple of boards with some different settings and see what works well for you on your machine with your router bits and the particular kind of material that you're using. Just a little side note here, there are a lot of router bits on a lot of major manufacturers do provide chip load and cutting and feed recommendations with their router bits. Unfortunately, for those of you who are using a benchtop tool, those settings really are intended for full-size industrial machines or commercial machines, such as the cabinet making industry. And they tend to be too aggressive for a small benchtop tool. For one thing, you'll often find feed rates in there of, easily in the 400 range. And although the HD6 will go that fast, the drive motors on the HD6 may not, depending on what kind of material you're cutting and how deep you're cutting with it, you still may be putting too much load on your benchtop tool. So be somewhat cautious if you are using the settings from a manufacturer on a benchtop tool. And especially for those of you using a Shark product, a Next Wave product, start out with some of these settings and do some experimenting, and that should keep you in a safe ballpark for your cutting. Now, the settings on the V-bit, you're going to see the same discussion here, much like we just went over. The one thing I want to point out here is that what's somewhat unique about the V-bit is you have something called a final pass step over and a clearance pass step over. So it actually does the step over in two different settings. The clearance pass is exactly what it says. It's going to go in and hog out the majority of the material with a much larger step over. You can see it's 10 times bigger than the final step pass over. So that's why you have those two settings. Now this 20%, you can go push that up to 40%. And save some time on that, depending on how your project is set up and whether you're using also a clearance bit with your V-bit. But somewhere between 20 and 40 usually works out well. Again, your chip loads will typically run a little smaller on this, probably up to 0.005. And you're probably going to run a little on the higher side of your router speed, just because of that tip on there. It's a smaller diameter at the tip, and you want to keep that cutting. So you can check out those, give those a try. And then on the basic ball nose, this is set up for a 3D finishing. And the thing that's most unique about the ball nose for a 3D finishing cut is notice how tiny our step over is. We're only using a 5% step over, rather than the typical 40% step over or 20% step over on the other tools. And that's because when you're doing the finishing, the 3D finishing, you're just using a small step over, so you get a nice smooth finish. Now that step over could range from 5 to 10%, but I find that anything much over, 8 or 9%, you start to see some noticeable machine marks. Now it takes a lot longer when you drop it down to 5%, but you will get a lot smoother finish. There's also some other tricks that you can do, and we'll look at that when we get into more into the VCarve demonstration part of it. The tool pathing. So with those three, you can use that information. That information also, if you go out to the support website underneath webinars, you'll see this 4-part VCarve series out here. This is a 4-part training I did a year or so ago. And within part 2, I go into a lot more detail on setting up tool paths and picking bits and what they're used for. So check that out if you're just getting started, you want more detailed information on how to set up a tool path. At this point, we're going to take and just do a couple quick tool paths I already have preset up over here. Let's take and just move that 3D shape out of the way. To start with, we're going to take a look at the profile. Now let me split my view here. There we go. Make a couple of adjustments. Okay, so that represents, we're cutting through, I'm using a a rectangle here that only actually cuts all the way through both sides of my board that you see up here. And if I highlight the solid view, notice the solid wireframe right here. Okay, so let's zoom in on this leg right here. This is the vector line that I'm working with. I've added this vector line only to show you that it has some, or it cuts to that side of the line. So let's open up the preview here, the toolpath. Let's uncheck some of these preferences. And I'm going to cut all the way through the 3/4 inch material. I'm using a 1/4 inch router bit. I'm going to cut to the outside of my vector, and let's calculate that out. And once again there, with a zoom in, we can see how it's cutting between, well, it's cutting to the outside of this line, but this line is offset by a 1/4 inch. So you can see that's the width of our bit. Now, one of the things that comes up is sometimes people want to add, when they're cutting a part, they want to overcut it or undercut it in size. And rather than changing the size of your vector, you can use a setup option in here called allowance offset. So right now I'm cutting to the outside of that vector. If I add an allowance offset of, let's say, 0.02, and that's going to push my toolpath a little bit beyond that line because I'm at the outside, it's going to add that much more distance to it. And there you can see how it pushed it over by that amount. So if for some reason you wanted to overcut that part by a certain amount, you would simply go in and add that overcut or that allowance offset, and it would offset it by that amount. Now we're cutting, like I said, we're cutting to the outside. This is a positive number, so it's going to be a positive offset further to the outside. Now, if we add a negative offset, it'll actually shift it to the other side. So there, it shifted it by 0.02 in that direction. So you just have to play with it. That's why I like this preview, because it actually shows you where it's going to cut. And now if we cut to the inside, and let's go back and put a positive, because we're cutting to the inside, it's actually moving it further to the inside. And in the same way, if we cut a negative, it'll then move it the other direction. So you have a lot of control going back and forth with where your exact position of your toolpath is. And again, this depends, one application for this is if you made a puzzle part, or if you looked at that name project, that name puzzle I did a while back, you'll see that I use this allowance offset to make those puzzle pieces fit in to their pockets better. So that's one option that is used for. Now, one other thing to look at in this setup, let's take off the allowance offset right now, and let's recalculate that. And let's go back and put that to the outside. And that's the typical location. Okay, so that's our basic default location on the outside. Now I'm going to run this, and there, we've cut it. Now, to understand what you're looking at in the bottom view here, there's our kerf from our router bit, and the end of these blue lines represents the middle of the router bit. So that's what that, of course, represents. It's cutting right down through the middle. Now, when we did our offset, it was cutting further to the left or further to the right. But there's another setting in here, which is similar to what we did when we did our cleanup pass with the VCarving. Sometimes when you run this straight bit, you will actually get little witness lines along the edge of that piece from the bit, little bit lines, or every depth or every pass will show up with a little line. And the one way to get rid of that, if you're using this, if this project of yours, and you're wanting this edge to be nice and smooth and without any of those lines on it, one thing you could do is go in and add what's called a last pass. And what that does is, if you look at the drawing right here, the first pass is step away from the project, away from the vector line, kind of like the offset. So let's type in 0.01. That I'll usually use a 0.01 maybe 0.005 or 0.00 or 0.02. You don't need a lot, but usually 0.01 will be enough to clean it up. You also don't want to use be too aggressive here, because it is going to cut that entire edge in one pass when it comes back for the last pass. Go ahead and calculate that out. Okay, let's select our vector. And then let's reset that. Let me double check this to make sure I have that. Okay, there we are. Okay, that looks good. Okay, calculate that again. And then let's go ahead and we're going to run this. Okay, see that little notch right there? That's the last pass. So the router bit was coming down here, and then the last pass, it shifted over all the way over here. If we look at the tool path, it's a little hard to see here, but let's zoom in. You can see how this one is a little shorter. So again, that's that last pass that's moving the router bit over in that direction. And then it cuts that entire edge. I sometimes call this a jointing cut or a cleanup cut, because it'll just take that little bit of material off. And it's a real handy way to do that. You can also see up here that we have an extra material right here, because the first part of that cutting is being done at an offset, and then the final pass is being done right up to the line. So it's a good way to clean up the edge of a project if you need that edge particularly clean and you're getting some tool marks along the edge. So with that, let's go back and take a look at the VCarving. So your standard VCarving setup, turn this off for a minute. And if I calculate that, and let's take a look and refresh this. I'll enlarge this. Now you can see how we have some coarse lines and some fine lines. These lines that are wide apart, that's our clearance path, and then these lines are close together is the finish cutting. So you'll notice as this cuts out, let me go back and double check, see what our setup is at. Okay, we're doing a 20% step over, that looks good. And let's calculate that out again, and let's preview this. So there's the roughing, and then there's the finishing. So that's the difference between those two tool setups. Now, it's pretty common when you're doing V-carving like this to even save more time and get a smoother bottom is go ahead and add a clearance bit. So in this case, I'll add a 1/4 inch bit to do the cleanup at the bottom. Let's calculate that out. Select our vector, reset that, and now we'll do the clearance pass first. That's the straight bit. You can see how that's just roughing that out, and then we'll go back, and now the V bit is only going to do around the edge and inside those points where the straight bit was not able to reach. So that gives you a much cleaner base. Now, here's one of the situations that often comes up, is that sometimes you'll find that your V bit or your straight bit, after you're done cutting these two, that one will have cut deeper than the other. Now, let's say that the straight bit is cutting a little bit deeper. The way to solve that then, because let's say these ends, these little pieces here at the end are a little thicker and it didn't cut all the way down to the depth at the bottom. You might also have a little ridge along the edge because the V-bit didn't cut deep enough. It's a pretty easy fix with that, because what you could do is go back into your V-bit, and actually I've already got it set up here, but what you would do is you go in and add a little start depth and then recalculate that, and then only run your V-bit. So what that's going to do, just like with our cleanup pass on the other V-carving, it's going to drop that router bit down, that V bit down a little bit. Like if you've calculated that that little area there is, let's say it's a paper thickness or maybe a business card thickness too thick, then that's what your start depth would be set at. And that'll push that router bit down a little bit and come back and clean that up. Again, it's not always required. Sometimes you could go in there with a sharp chisel and clean that corner up and maybe you'll be just fine. But sometimes it can be a problem. And the reason it comes up is it depends on a couple of things. First of all, one of the most basic causes of it is the fact that when you zero the bit, the V bit and the straight bit, is that they didn't zero exactly to the same height. That's really what's causing this. And that can happen because sometimes V bits will poke down inside the aluminum touch plate a little bit and you get a slightly different reading, or the straight bit, because it's wider, will tend to zero a little differently. Also, when you're zeroing with your touch plate, make sure to do it off the same part of your material with all your bits, because one of your corners might be a little higher or lower. And if you start zeroing off of two different corners of your project or a different location, you may get different readings. But if you've been careful with all of that, you could also go back and add that little clearance pass. We just showed you how to do a little start pass on that, add a little start depth, and that'll clean it up. Now, if it's the other way around, if it is in fact the straight bit, or rather the V bit is cutting too deep, then you could just do the opposite, add a little start depth, but then run the clearance pass instead to lower that flat area down. Now, if you consistently are getting a variation between your two bits like that, you could just simply set up two separate passes or two separate tool paths, one that's cutting deeper than the other. Or you could also just slip a couple pieces of paper under your touch plate for the one that is cutting, let's see, that would be cutting too shallow, or rather the one that's cutting too deep, slip a couple pieces of paper to the touch plate and that'll zero that bit a little bit higher so it won't cut so deep. So again, that's another little trick that if you want to, when you're doing your initial Z, if one of your bits is always zeroing a little too deep, then just put a little paper, a couple of sheets of paper under your touch plate. It'll cause it to zero a little higher. But a couple of things with the VCarving setup. The last one we mentioned earlier was, or the last bit we looked at, was the 3D finishing. And again, here, a couple tricks there to get good results. The first thing is, again, using a step over of 5 to 8%. I'm usually in that range someplace. But for this example, I'm going to put it at 10, which is a little on the high side. And let's calculate this out. Takes a minute to do that. Let's reset that and preview that. And there you can see it's going with the grain in the vertical direction. That's usually what I do when I use solid wood. I'll go with the grain. That leaves the best results. But we still see some tool marks in here, and that's partly because we're at 10%. But even at 5%, depending on the wood you're using, if you're seeing some tool marks, I know some guys that really want to try and eliminate as much sanding as possible. And the way to solve that is to duplicate that tool path. And actually, it looks like I may already have a duplicate, but let's just use this one. I'm going to open this one up. And what I'm going to do is I'm going to change the machining direction, the opposite direction. And now you can see it's running horizontal, and now it's going to go back the other way, and it's going to clean up a lot of those existing tool marks. So I would typically run the horizontal one first, and then go back and run the one that runs with the grain, because that'll leave the least marks. It's the easiest to sand them out. But adding a cross network of paths, of tool paths, one going vertical, one going horizontal, or at some other angle, it does actually produce a smoother surface. Now it doubles your machining time, so you may or may not want to do that, but it is just another trick that you could use if you have a critical carving that you just don't want to go back and sand, or it's really hard to sand. You know, this is a very simple shape. This would be an easy shape to sand, but if you have some, you know, like a picture of an animal or some landscape or something like that, some complex 3D carving, then going both directions can actually help clean it up a lot. So next up, let's take a look at snaps. And snaps are a handy way, and alignments and such. Now, snaps specifically, there are 3 snaps available. You've got geometric snapping, smart snapping, and grid snapping. And those options are available up here in the right. And when you click on them, when they glow blue, that means they are active. So I just activated the grid snapping, and you can see how you have some dots on the work area here for the grid snapping. And the way grid snapping works is if I hold the cursor over it, you can see I'm getting that cursor has those 4 plus marks around it. And now I can just, it'll snap from grid to grid. So that's if you have a grid set up, whatever that, and you can just snap specifically to that dimension. So in this case, I've got a 1/4-inch grid set up. So everything is based around 1/4-inch increments. So if you're designing a project, you want everything around 1/4-inch increments. That's a handy way to do it. That grid size is editable, and I'll show you that in a minute. The other way that grids can be used is that if I'm moving an object, I can grab the middle of that object and I can snap that to a grid. So the center point is right there on a grid, or I could take the corner and I could snap that to a grid point as well. So grids both work for drawing and for adjusting the position of objects. Now the smart snapping, the one in the middle here, I'm going to turn those other 2 off. The smart snapping is a kind of a alignment tool on the fly. So if I grab this project and I just move it, see that horizontal line? That's showing me I'm going to be able to consistently move this shape in the horizontal. Now it's picking up some other objects, but I can also go straight up with it like that. I let go of it. Now if I go left or right, you can see the horizontal line. And that's part of what smart snapping is. The other thing that smart snapping does is, let's grab a corner. I can go to that corner and I can drag it out and stay in alignment with that corner. Also, let's drag it down here for a minute. Put this one over here. Now, let's say that I wanted to take this shape, and I can drag this up to the top of that, go over, but I can also touch that corner right there. Now notice it'll give me a horizontal and a vertical line. So now the corner, this upper left corner of this little rectangle, is aligned with the left side and the top side. So that's another thing that snaps do. Snaps will also recognize the midpoint on a project. So the midpoint on the side or the midpoint on the bottom like that. Or if I grab the midpoint, it'll line it up like that. The third snap that's commonly used is the geometric snapping. So let's turn that on. We'll turn off the smart snapping. Geometric snapping specifically has to do with aligning parts of this object to another object. So let's grab that corner. And if I want to align it to this corner, it'll snap right to that corner. I could grab this lower right corner, snap it to the upper left corner, and you could build like that and just snap things wherever you want them. Also, you can grab the middle, it'll snap it to the middle of the other side, or it'll snap it to the middle of a circle like that and put it right in the middle. Even ellipses, if you want to snap it to the middle of that rectangle, it'll snap it over there. So that's geometric snapping based on the shape of the object. One other alignment tool you have, or a couple of you have, is you have grid, or rather guidelines, okay? And guidelines, this little tool up here, you can make them visible, you can delete them, you can lock them and unlock them. But the basic way to create a grid is go over to the left side, left click, hold the left mouse button down and just drag it over, and then grab the top one and drag it down too. Now notice I've got a dimension there. And so let's drag it down to, put it right there at 2 inches. Let's grab this one and let's take that, leave that at 3 inches. So that's based on a dimension from your 0 point. So I'm 3 inches over and 2 inches up. Now, if I want to use, I can take that up and that'll snap right to the inside corner like that. Or if I want to use that guideline to start my rectangle, I can start from there as well. Think about guidelines. They are not vector lines. They will not, you can't toolpath them. They're simply there just to help align objects too. Now I could grab, you can add as many as you want. Like that, you could just keep dragging them down as many as you want, or you could even align it to an existing object. See if we can do that. There we go. And if you want to get rid of them, you could either drag them back off the screen like that, or go under View, Guidelines. You could delete them or turn off their visibility and just temporarily hide them. And then they're hidden. And the last tool that's related to snaps and alignment are your align object tools. We won't take a look at all those individually, but if you don't have your align object tools showing on your main menu on the left, the way to activate that is go inside the single align tool right here, open up the main menu, and in this menu, it gives you a description on what they are. And if you haven't used these, again, I recommend click on that question mark, go out to the Vectric website, and it'll give you an explanation of what all of these do. It's somewhat explanatory, is that it's going to move the one shape to align to the other one, in this case, to the bottom edges of both of them. On this one up here, it aligns it to the material, which is this white area. To these, it aligns one vector to another vector. But if you check these boxes down at the bottom, you check that box, that will then bring an icon for all of those alignment tools on your main menu, so they are readily available. So next up, let's take a look at texture. There was a couple of questions that came in on texturing. Basically, the question was, does the texture toolpath take passes in one pass or multiple passes? And the short answer is it does it in a single pass. And so you have to be aware of that so you're not cutting too deep. But let's go ahead and open up. I'm going to go ahead and add a new texture toolpath right here. I'm going to select that vector. I'm going to go ahead and check my settings on this. And okay, so I'm going to pass depth. Let me change that pass depth to 0.05, just a little under a 1/16 of an inch. And then I'm going to do a maximum cut here of 0.125. So this, in most tool settings, if you're doing a total depth of 1/8 of an inch in this case, but your pass depth is set at 0.05, that would suggest that this is going to take several passes in order to get down to that final depth. But for texturing, that's not the case. In fact, we'll just run a calculation on this and we'll be able to see it. So if we zoom in here, the red lines are where it's moving in the air from toolpath to toolpath. The light aqua lines and green lines are where it's descending and ascending. The blue lines right here at the bottom are the actual cutting direction. So you can see it's cutting each one of those scoops in a single pass. So you have to be a little careful. If you have your toolpath texture set up, and let's say you set this at 0.5, which is a 1/2 inch, it's going to cut those each in a single pass. And that is quite aggressive for almost any router bit. That's a pretty aggressive cut. So you may want to find out a way to hog this out first before you do that. I don't find that, I mean, this texturing is kind of interesting, but you got a lot of sharp points in there, and I don't find it overall that useful. So that's why usually on an 1/8 inch bit or 1/4 inch bit, I'm usually only cutting 0.05, which is even my pass depth. And let's recalculate that, reset that, preview that. And to me, that gives me a much more interesting texture, and it's not overly aggressive. So yes, the Texuturing Toolpath will cut it all in one pass. So just be aware of that. Another set of questions that came in had to do with joining and node editing. And this is a big topic in itself, but this is really useful when you're doing custom layout or you have lines that you want to join together, weld together. But once again, if you go out to the support website, webinars, you're going to find a section, part 3 in this Intro to VCarve class. It specifically covers vector and node editing, and you'll find information on that out there with a lot more detail that I'm going to cover right now, but that's a great resource to go to. Also, the Vectric website, you're going to find some great help out there also on node editing as well as joining. So check both those out. But I'll just give you a quick overview of the basic tools and how it's done. So this is just a couple of lines here that I've created. Now these lines may, they can come up with different, you might have different shape lines. Let's draw another shape here. Draw a circle. And let's cut, some things like that. We'll just have a couple of shapes we'll be dealing with. But if we wanted to join these two, whether they're close together or far apart, if I select those like that, the first thing, it depends on what you want to do. If you want a rounded end on those, then an easy way to do that is use this join tool over here with a smooth curve. And that'll give you, it won't give you a fillet, but it will give you kind of a rounded shape on the end. Another way to join these is to use this, select those, and use this tool, which is to move the points. Now, this actually changes the design quite a bit, but it moves them to a nice sharp point, and that may work for your design. That's why it's available. Another option. Another option is just to add in a straight pass on it, and that might work for your design depending on what you're doing. But when you have where you may want to have these just come down to the common point, rather than trying to stretch these lines, there's this tool right here, which is really handy. It's called an extend tool. And if I go out here, notice I'm getting that dotted line. Let's click once on that. Go down to this one, it goes over there, click again, and close out of that, and it automatically brings those lines. Now, it didn't join them, but it did extend them. So now that I have those extended, I could go into this tool called a join tool, which basically is used for when you have really close a joint like this. Notice up here, it says that right now we don't have any closed objects, but we do have 2 open ones. And the reason it's saying we have 2 open ones is because that's an open object and that's an open line. And after we join them, we'll have 1 open one because it's just those 2 are joined together. So now this is 1 continuous line. Let's do 1 more line in here. We're going to go up here and I'm going to do something like this. Now, if we want to clean up this shape, a simple thing to do would be to trim these ends off. And because this box is checked, it's going to show us that it will rejoin those. Now, to join these together, again, we could select those and just move those points, but this seems like a good option to use that extend option. We'll click on that one and that one. Now the question, is that a joined shape? Well, one easy way to find out is to click on our Join Open Vectors tool and it shows that we've had one closed vector. So when it extended it, in that case, it automatically closed it. So now we have one continuous vector all the way around. Now, a couple of quick things. I mean, this whole design here, this trim tool I was using, you could go in and trim out. And because I have that checkbox joined, it automatically joins those lines together. Now, node editing, if you, again, just a couple quick things on node editing, because I go into great detail on that class, and that's probably a good place to go if you want to find some detailed information on node editing. But let's just go into node editing. So I right-click to bring up this local menu, and I have these various nodes. Now, when you go in and go over a node like that, and you right-click, you get this local menu. And the ones that are highlighted, especially at the top up here, these are the ones that tell you what you can do at that point. So I can delete it, I can smooth it, I can cut it, or I can make it a start point. The start point is represented by this green point. And that, even though it's a closed object, that's the beginning. Even a circle, it's like, think of it as a string that's connected on the end, or like take an extension cord and plug it into itself. It does have to have a start point. And most of the time, the start point, this comes into play later, sometimes with tool pathing and other things. But if you wanted to change the start point, let's click there. I just changed the start point to that location. Now let's go back down to this one, and let's cut that vector. Now it's like, well, what happened? I don't see anything happen. Well, actually, if I go in and grab that point and I drag it down, notice how it's actually separated because I cut it. And then if I were to go in and go over the line, when you go over the line, you see a little line symbol there below the cursor head. Now I have a list of things that I can do with that line. And let's do an insert point. So I can actually insert the point. And notice this little gray dot, that's a midpoint. And if I stretch on that, it'll automatically turn it into a vector. And I have more midpoints here, so I can keep moving this around if I like. And if I don't like this point right here, I could go in and hit delete point or the D key, like that. Or if I want, I could go in and smooth that point, and then I get these Bezier curves in here, and I can do lots of custom shapes with that. Or again, I can delete that. Now I just have a Bezier curve right there with these handles. If I wanted that to be a perfect arc, I could convert that to an arc, and now I have a perfect half circle or part of a curve that I can stretch that up and down. So that's a quick overview on nodes. If you want to know more about that, check out the Vectric website as well as that VCarve class on the Next Wave website. Next up, had a couple questions about creating raised lettering. And you basically have three options for creating raised lettering. You have a prism approach, a VCarve approach, and a straight approach. And the straight approach is often what people are tempted to use, and it is very simple. And the way it's done is you have some vectors set up. You have your letters, and I have an outline here for around it. And I simply use a pocketing toolpath. So I set this up. I'm going to use a 1/4 inch and 1/8 inch bit for two setups. I'm going to go a 1/4 inch deep. I select those vectors. I calculate it out. And then I have the two toolpaths. We'll use the large one first, preview that. And then go back and clean up the rest with the smaller bit like that. That gives you very sharp letters. Now, one of the drawbacks of this is if you have letters that have little fine points in it, these parts can chip off. It just depends on the size of your letter. So just be aware of that. It gives you a very crisp letter, but because wood being what it is, if you were dealing with some fairly small letters, or if your letters had some serifs on them that were really skinny, those pieces can break off. So that is the downside of this approach. The other approach, probably my favorite, is actually what I call reverse V-carving. Again, you're using the same setup vectors, but you're using it border and the letters. And in this case, what happens is we're going to clear it out again with the 1/4 inch bit, and then go clear out a little bit more with an 1/8 inch bit, and then finish it up with the V-carving, and it'll go around and give us that nice angle around the edge, like that. It does give a very different look. What's nice about this is because it gives it some character, but also that tapered edge actually adds strength. If you have skinny areas in your lettering, it'll add some strength to those areas. Now, the last one is the prism. This is a special application, and it's going to depend on your project whether this is applicable or not. But the way this is set up is you open up your prism tool. Now, the prism tool is right up here, prism carving. I've already got one pre-configured. In this case, I'm going to select my lettering, and it will help predetermine what angle you need. In this case, I'm going to put it set full prism. If we look at that, you can see full prism means it's going to get a point, or get the top of the pyramid is going to be right there at the top. It's going to be intersecting all the way around. So let's calculate that out. Let's select our vectors, reset that, and preview that. Now that looks a little odd how that is all set up like that, but that's where we need to go back and clean up the background. So for that, we select all of those, but then I have this pocket area set up again, just like before. So we'll pocket out with the 1/4 inch bit, and then go back with the 1/8 inch bit. Now, one of the limits to that, you can see right in here, the 1/8 inch bit did not reach in there. So not a lot you can do about that, but there are a couple of other options. It depends a little on the shape of your letter. But if we were to go in and on our pocket, I've got this pocket set at the same depth as my letter carving. If I were to set this at a 1/2 inch deep, you could actually create another effect on this. So let's preview the visible. So notice how now we have a nice flat edge on that. So that provides a whole different look. And let's go into the prism carving, and rather than doing let's change that to a 0.125. Now that may give us an error. Yeah, it's telling us we're not going to get a full prism shape out of it, but that's okay. Let's preview all these. I need to reset. Preview all the visible. So there's another modification. There you can see how without doing a full prism, we get a nice little bevel around the whole letter. And we get a little flat on the top. So these, again, are basically the 3 ways that you could do letters. There's certainly some customizing you could do with any of these. And there's even some other ways for creating letters if you were to do letters separately. But hopefully that's helpful to those of you who are looking to do some raised lettering. Give it a try, experiment with these, and good luck with that. It's a fun way to do lettering. But the last question we're going to look at has to deal with one of the new apps that came out from Vectric, and that is their EasyCreate. Now, EasyCreate makes use of artificial intelligence and AI app for creating images and for modifying images. And they have a whole series of tutorials out there at their YouTube website, as well as on their website, on their business website and on YouTube. So go out and check those out. They're really helpful. But the gist of it is that you'll enter a photograph or have it create an image for you. It'll have you do it either way. You buy what are called credits. So I think it's $20 for 200 credits. And I think it takes like 5 credits approximately to do a design somewhere in that neighborhood. But in this case, I imported this photo that I had of these wood ducks, and then I went in and put it into the website, and then out of it, within only a minute or less, came this image right here, this 3D carved image. And let's take a look at what it looks like here. It's really pretty amazing. If we look at the 2 images side by side, part of it that I find fascinating is not only did it add a lot of this added detail, but it actually added the stylized water around it, which isn't necessarily in the image up above. So because it's AI, it has knowledge of what wood ducks and water looks like, and it enhanced it and added that extra shape to it, which I really like. And I also had it remove the background so that I'm just dealing with this minimal amount. So now if we look at the side, this is about a 1/2 inch tall. So that's not too bad. I could go back if I wanted to. Let's enlarge that page. Having imported that, I could also go into my components. So there's my wood ducks. I could open that up, and right now I'm about a 1/2 inch thick. If I wanted that a 1/4 inch thick, I could change that. And of course, I'm going to lose a little bit of detail, but it still looks pretty good. But that way I wouldn't need it quite as thick. Close out of that. I can then go in and run my toolpaths on that. I already have some set up, so let's see how they look. Let's do the roughing. So there I'm using a straight bit to do the roughing. We'll do 2 3D finishes. So this will be actually this is another clearance bit. This is the clearance, so this will be another bit to clean that up. Notice I'm going across the grain in this case. Probably if I ran this picture, I'd actually have the grain going horizontal, and that's why I ran that direction. Let's see how this one goes. So then so that's an 1/8 inch bit going over the entire surface. The 16th inch ball nose bit is just going to come in and pick up on some of those details and clean it up. And again, that's pretty impressive considering I start out with a photograph, and within probably 5 minutes of bringing that photo into VCarve, I was able to preview what my carving is going to look like. So it does cost a little bit for each image, but if you have images of, pets or family or landscapes or, things like that, or if you wanted to generate something for you, it's a pretty amazing option. This has been long coming. I remember years ago, Vectric introduced a 3D modeling thing where you put a photograph in and it simulated it, but it didn't come back with the highest quality. And but now this is a really straightforward way of doing it. So I can see myself and a lot of people just using this a lot now. So hopefully that's been helpful. Thanks for joining us for this series, this episode. This time. And again, you'll find some of the links to some of the resources spoken about in the description below this video, or for those of you who are online live, you can also find those in your email. So thanks for joining us. Have a good day, and I'll see you next time.